Hello everyone, hope you are doing well. I am your instructor, Akshar Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT ICT department. Welcome back to the video tutorial series of the Internet of Things. Right? In that, we are learning that microcontroller, right? So in this today's session, we are going to learn two more microcontroller. Which are they? As you are aware about the Node MCU and the gateways, right? So we are seeing that Node MCU and the gateway in brief in today's session, right? So what do you mean by the Node MCU, right? The Node MCU is an open source firmware and the development kit that help you to prototype your IoT product within a few LUA script lines, right? Whenever you want to build and prototype of your IoT product, then you can use that Node MCU, and with the help of few Lua script lines, you can build and prototype of your IoT product, right? So what is the specification of the Node MCU, right? It is having an input voltage of 3.3 voltage. It is having a DC current of 250 milliampere, right? So you can you have one question, right? So what is the memory specification of the Node MCU, right? So the RAM is having a 32 KB of RAM, 80 KB of DRAM, and it is having an 30 KB of flash RAM, right? So that is a memory specification of a Node MCU, right? The Node MCU, the Node microcontroller unit, right? So what do you mean by that MCU? The microcontroller unit, right? So the Node microcontroller unit is an open source software and hardware development environment that is built around a very inexpensive system on a chip, SoC called ESP8266, right? The basic fundamental component of a Node MCU is ESP8266, right? It is look like an Arduino like devices, right? So one question arises, sir, what is the similar kind of thing of Node MCU? It is an Arduino like device, right? After that, its main component is ESP8266, right? With then programmable pins, you can connect then so many input and output devices, and it is having a built-in Wi-Fi, right? You can give the power to the Node MCU with the help of USB. It is really low cost device, right? So you can develop your IoT prototype with the help of Node MCU, right? You can what you can do with the Node MCU, right? You can program it with the help of C or Lua, right? You can connect or you can access that Node MCU with the help of Wi-Fi, for example HTTP, Hypertext Transfer Protocol, and kind of thing, right? After that, with the help of that connecting pins, you can connect any devices, right? Input or output device you can connect with the help of that connecting pins, right? So this kind of the thing you can do with the help of Node microcontroller unit, or you are aware about Node MCU, right? So that are the basic development board version 1 of the Node MCU, right? That is an example of version 1 of the Node MCU. That is core component is ESP8266, right? It is having a 3.3 voltage of LDO regulator, 800 milliampere of SOT33. Let's see the ESP8266 in brief, right? ESP8266 is a highly integrated chip designed for the need for the new connected world. ESP8266 is highly integrated chip designed for need of new connected world, right? It offers a complete and self-contained Wi-Fi network solution, allowing it to either host the application or the offload all Wi-Fi network function from another application processors, right? ESP8266 has powerful onboard processing and storage capability that allows it to be integrated with the sensor, the specified device throughout its GPU pins with minimal development upfront and minimal loading during runtime, right? So that's how that ESP8266 is running. Let's see the pin out function or pin out diagram of ESP8266 of the Node MCU, right? Let's see the basic function of Node microcontroller unit, right? It is obviously the open source unit, right? After that, it is interactive device, right? With the help of input output device, we can interact with the Node MCU, right? After that, it is easily programmable with the help of C or Lua scripting language, right? With because of its low cost components, its cost is really low compared to the other devices, right? It is simple to work with and smarter than the devices, right? And it is having a pre-built Wi-Fi technologies, right? Let's see the pin function of a node MCU. Input output pins, right? So for that, the digital pins from the pin number D0 to pin number D10, we are having a 11 digital pins. We are working with a node MCU, right? After that, we are having a 12 PWM pins enabled in the node MCU, and we are having a one analog pin, which is that is a pin number A0 is an analog pin which is embedded on node MCU, right? After that, for the power pins, right? So for the power pins, the ground pins, we are having a 5 ground pins, 3.3 voltage 3 pins, and we are having a V in pin 1, adding the external supply of 5 voltage if it is not connected to the USB, right? So that are the power pins, and that are the input and output pins which is embedded on the node MCU, right? The development kit based on ESP8266 is integrated GPIO, PWM, IIC, one wire and EDC all in one board, right? USB TTL and included plug and play, right? We are having a 10 GPU pins. Every GPIO pin can be PWM, I2C or one wire, right? After that, we are having an USB plug and play devices and PCB antennas too, right? So whenever you have one question arise, what if we we are newbie to node MCU and we want to start working with node MCU, right? So for that, you have to install Arduino IDE, right? Install the Arduino IDE, right? From its Arduino website, you can from the software section you can download that Arduino IDE, right? And after that, install that ESP8266 add-on into that Arduino IDE, right? And boom, you can work with node MCU, the node microcontroller unit, right? So let's see the simple code of an LED blinking. The first function is a void setup, right? With the help of that, we can start the setup of that. After that, the pin number 13 is our pin of output. Why the looping? We are constantly blinking that LED line, right? We are giving an high voltage to the pin number 13, which will we will blink the LED light bright, right? And after that, we are waiting for the 1 second, right? And after that 1 second, we are keeping back that power from that pin number 13, right? So we are keeping that pin number 13 low for the another 1 second, right? That process is doing iteratively in that particular loop, right? So in the setup function, we are having a pin number 13 as an output pin, right? All that function we are working on the particular pin number 13, right? In that loop, we are giving a high voltage and the low voltage to the pin number 13 because we have selected that pin number 13 as an output pin, right? So pin mode of the pin number 13 is output, right? So we can give the power to the pin number 13 and we cannot give the power to the pin number 13. We can give high power to the pin number 13 and we can give low power to the pin number 13. If we give a high voltage or if we are giving a high voltage to the pin number 13, then the LED which is connected with the pin number 13 will glow. And if we give the low voltage or the low power to the pin number 13, then that LED will not blink, right? So we are keeping this particular thing on the loop of delay of 1 second, right? So that is a sample code of the blinking the LED with the help of node MCU, right? So that's all about the node MCU, right? So let's begin with gateway, right? So what do you mean by the gateway, right? It is divided into the 3 parts in the IoT gateway: sensing domain, network domain, and the application domain, right? So let's begin with sensing domain gateway, right? It is interact and communicate things, right? It is consist of many things, information to realize the information of physical target, right? So to work with a physical target, we are having a sensing domain gateway, right? Using a wireless sensor network, WSN, RFID, the radio frequency identification, field bus, barcode, Zigbee, all are the example of the sensing domain gateway, right? It provides network domain with valuable things, right? The obstacle are low power, low cost, prototype, low weight, and all are the disadvantage of sensing domain gateway. The another type is network domain, right? It is evolved communication infrastructure. PSTN, 2G, 3G, LTE, satellite are the example of the network domain gateway, right? The main roles of to transfer the data which is collected from the sensing domain to the remote destination, right? Which is the main task of the network domain gateway. And another type is application domain, right? It takes responsibility for data processing and services, right? The data from transmission layer is handled by the application domain gateway, right? It is providing various services to the user. With the help of the application domain gateway, we can provide the user to the various services, right? Let's see the sensing domain network, right? In that PAN network, the personal area network, right? So what do you mean by the PAN network? The personal area network, right? This interacted sensing device around the person. It is using that smartphones, laptop, and the customized devices such as smartbands and these smart watches, right? This acted as an IoT gateway, control signaling, and the data transmitted the IoT gateway. A wired connected using an USB or the FireWire, right? A wireless connectivity using IRDA, Bluetooth, wireless USB, Zigbee, and Wi-Fi. All are the example of the wireless connectivity of the network, right? After that, the IoT gateway usually registered in the backend servers, right? After that, the vehicle network, right? The two type of the vehicle communication is there: inside the vehicle and from or to the vehicle, right? The vehicle IoT gateway collect the information of surrounding things such as road, rails, its obstacles, and all kind of things, right? The radio frequency identification technology is used there to improve the vehicle logistics, some quality control, tracking, and all kind of things, right? The dedicated short range communication is there into the vehicle network, right? The possible of the higher bitrate reduce the possibility of interface with other equipment, right? So with the help of that short range communication in the vehicle, you can achieve these tasks, right? The intelligent transportation system, right? It will be improve vehicle safety services and the traffic management, right? After that, the home network is there, right? It is constructed with the sensors, micro actuators, information homes, appliances, and all kind of things, right? The home network is constructed with the sensors, micro actuators, information home appliances, etc. Home IoT gateway interconnected multiple smart devices together, shares resources information, integrate several common network protocols, support the intercommunication among the equipment with a different kind of network protocol, right? It controls in-home smart equipment such as smart AC, smart washing machine, and kind of thing, right? Its contact external network need to access from the IoT gateway to 2G, 3G mobile communication network module. It can be managed smart things everywhere, right? Common feature of the IoT gateway, right? So let's see the feature of the IoT gateway. It's bridging the communication between sensing domain and the networking domain, right? What is the common feature of the gateway? It is bridging the communication between sensing domain and the network domain, right? It can be quite different from the application to application domain, right? The common from the IoT gateway, right? It is a common feature of the IoT gateway is that its manageability, right? It is managing that IoT gateway by itself, right? Backend IoT server provides an information such as subscription, authority, status, mobility, and all kind of data we can get from the backend IoT servers, right? IoT gateway have ability to manage a smart thing such as identity, control, diagnosis, configuration, all kind of data we can manage that things with the help of IoT gateway, right? IoT gateway goals to bridge the various sensing domain network with public communication network or internet, right? That is a reference model of an IoT gateway. We are having several application 1, 2, and 3, right? So in that we are having a security module and we are having a management module, right? In the security module, we are having a service abstraction module, protocol conversion, and the data forwarding modules, adapting modules, and all kind of thing is there. right? For such as Zigbee and all kind of thing, right? So let's see one by one component of the reference model of IoT gateway, right? Service abstraction module, right? It is having an address fragmentation of IoT application. The several functions of service abstraction modules are uniform interface for service provider to simplify application development. IoT application developers do not need to deep understand of underlying technologies. Enable underlying networks to use IoT optimization, right? IoT gateway system uses the short distance wireless communication protocols such as Zigbee and Bluetooth, right? Adoption module focus on adoption of the packet size of two different network address resolution. For an example, IPv6 packet transmitted over the IEEE 802.15.4 networks, right? Protocol conversions and the data forwarding modules, right? Interact with the service abstraction module, adaptation module, multiple interface module, right? It is analyzed that repackage the sensing data based on the short distance communication protocol. They capsulated inside the data based on the telecommunication protocol. It transfers the data from one network to the another network correctly, right? So that is a basic task of protocol conversion and data forwarding module. The another module is application profile module and the network profile module. It provides a context of to multiple interface module. It is help the multi-interface module can decision to use network interface, right? After that, the application profile module is that it is providing that application level information and cache watch the type and the number of applications that is currently running, right? After that, in the security and the management module, it is based on ICT system, right? Security provide access control with the help of data integrity, privacy protection and kind of thing, right? The management provide and management network power, fault, authority, status and mobility. We are getting all kind of information with the help of security and management module, right? So that's all about node MCU and the gateway, right? So that's all about the microcontrollers too, right? So that's all about today's session. Thank you for the watching.